a scientific theory of the universe, not of the matter, like the galaxies spread within a given space-time of the universe, but the actual theory of the universe as a whole, the space and the time, the matter and the energy. And lo and behold, what did his equations predict? And this is not something that he knew in advance when he put into the equations. He came up with the equations through brilliant insight and a tremendous intuition. And he came up with these beautiful equations after many years of various attempts. And the equations, which were solved also by other people, showed that the universe was not static. His equations also showed something so radical that even he himself was willing to accept. And that was that the universe is also finite in time. If you solve his equations for the universe, lo and behold, what did his equations predict? The universe is expanding. What does it mean that the universe is expanding? It means that the space of the universe is expanding. Not that there's an empty space like in the Newtonian conception, and there's matter like galaxies, and the galaxies are spreading apart further and further into some kind of a void. No. It's the actual space of the universe which is increasing. It's a very, very difficult concept. It seems totally counterintuitive, but that's what it is. You have galaxies. You have a distance between neighboring galaxies, and the distance between them gets larger as time goes on without them moving, because the space between them is expanding. Effectively, to us, we see them moving apart from each other. But it's not that they're moving apart, it's just simply that the space between them is getting larger. Now, if you extrapolate that backwards, if you say, well, 1 second, all these galaxies are moving apart. If they're moving apart, and this was the case before, then a little while ago, the universe was a smaller place. There was less space in the universe. And even further back in time, it was even smaller. And further back in time, it was tiny. And everything would coalesce into basically the point. And that's where kind of space-time seems to annihilate. There just isn't anymore. What that means is that at some finite amount of time in the past, the universe began. You have a theory. You say, well, the universe, it's expanding. It's getting larger. It was smaller before. That's a nice theory. You have a nice equation, but you don't just accept a conclusion like that without evidence. You have to have an experiment, make a prediction, see what the evidence is. Now, of course, we can't just create universes and see if they expand, but there's a universe out there for us to look at, and people did. Now, what would be a consequence of an expansion of the universe that one could measure? But if the space in between the galaxies is increasing, according to this theory, then one should observe the same kind of pattern. Wherever one would stand in the universe, in whatever galaxy, one should see all the neighboring galaxies moving away. And the further the galaxies would be from you, the faster they should be moving. Now, how do you measure such a thing? I mean, these are vast distances. And the answer is something really in a way prosaic. You may have heard ambulances and police cars and things like that coming towards you. And they come towards you, the sound, the frequency of the sound is different than when they leave you. And you may have studied this in physics, you can actually test it out on the street. Pay attention to the frequency of the sound. It's higher pitched when it's coming towards you, and lower pitched when it's moving away. All waves have this property, including light waves. When light is emitted by a galaxy of stars, and it's moving away from us, the light is shifted to a different color than if it's moving towards us. So we can tell by looking at the light that's coming from distant galaxies how fast it's moving and in what direction. And in fact, Slipher started these calculations, these observations, and Hubble completed them and did it in a more fundamental way. And he came up with exactly this relationship. The galaxies are receding from the Earth, or receding from our local galaxy the Milky Way, with a speed that's proportional to their distance from us. Now, you can have a paranoid interpretation of this, which is that all the galaxies are trying to run away from the Earth, and they're just trying to get as far as they can, and the further they are, the faster they're going, and so on. Or you can have a different assumption, which says that they're not really receding from us. Wherever you would stand in the universe, you would see the same pattern of recession. The Earth is not a special place. The Milky Way galaxy is not special. It's just like the dots on the balloon. Wherever you would stand, you would see this pattern. There's no way really to prove which one is true and which one is not. The old conception of the universe automatically assumed that the Earth was a special spot in the universe, and therefore they probably wouldn't make this assumption. Our opposite assumption that we make today is we don't assume a priori that the Earth or the Milky Way galaxy is any different than any other galaxy. That's a big assumption. Over time, more and more evidence accrued to support this theory, and the Big Bang theory basically is accepted as true. It starts at a point, space increases, it starts out as energy. Energy, as we know, can turn into mass. And in fact, as the universe expands, as the space expands, the energy cools off, so to speak, and becomes matter. The matter starts clumping into agglomerations of matter that we call stars and then planets and galaxies and so on. We have the whole structure of the universe. Then, on these planets, different things can happen. We have the theory of evolution that takes it on to the next step.
That was a question. Does the universe have an end? Does the universe have a beginning? Does the fact that it exists mean that it came into existence? In the same way, he came up with some kind of an answer to the conundrum about time. What happens when you extend time backwards? According to the theory of relativity, applied to the universe as a whole, and we'll see some of those equations. It turns out that the universe is expanding now, which means if you run the movie backwards in time, it was contracting. And it doesn't mean that the universe was contracting and there was more emptiness around it. But everything that we call the universe was getting smaller. So if there was a certain distance between here and there, that distance was decreasing. Not that the things were moving towards each other and therefore becoming more compact and leaving empty room, but space itself was contracting. So whatever amount of space there is in the universe now, there was less 1,000 years ago, and even lesser 10,000 years ago, and much, much less 100 million years ago, and extraordinarily less 15 billion years ago, until basically all of space-time, all of space was a point. Not a point in something else, but everything that was space was small as a point. So that there was no outside of space. Now again, these are concepts that's a little difficult to absorb the first time. If you think about it a little bit, you work out the equations, eventually you develop an intuition, after which it begins to seem natural. Every once in a while, though, you have like this little cognitive dissonance. You probably all have experienced. Sometimes you hear a word in English and you look at it and say, what word is that? How do you spell it? Have you experienced that? Every once in a while, right? So once in a while, you think you understand this idea and it makes all sense, but suddenly, what? I believe that. That makes sense. But overall, your intuition changes, and eventually it can wrap itself around this.
What happened was when people proposed this theory that the universe was expanding, based on Einstein's equations, if you trace things back in time, what happens? It's like elapsing, right? Elapsing backwards, so we're moving back in time. Eventually what happens? All the dots merge. Now, again, we're not talking about galaxies moving through space. We're talking about space itself. We're talking about space itself getting smaller. So that if you went in a straight line in one direction, you come back to where you started, now it would take you many billions of years. If you would have done it several billions of years ago, it would have taken you much less time because the space of the universe was less. If you move back in time enough, everything is concentrated in one point. It's just one big black hole. And all of space is one black hole. It's not a black hole in space. Now this, again, it's a difficult concept, but there is nothing outside this. All of space, space-time, is now a point. In quantum physics, which Einstein helped develop as well,
one understands that you cannot necessarily talk about ordinary concepts of space and time once you get to less than a certain minimum distance. So there's quantum cosmology, which deals with the universe when it's smaller than a certain amount. But basically, you get this picture of a point, and if you run time in the forward direction, you have a point with all of matter and energy in it, all of space and space-time is expanding. The energy in this space-time is turning into matter, is starting to coalesce according to the laws of gravity. Stars are forming, galaxies are forming, and eventually we have the universe as we have it now. Now, the equations also allow us to determine how much time would it have taken to get from here to that. You just trace the equations back in time. How long ago was all of space-time this point? And the number that pops out of the theory of the equation is 15 billion years. And that's where the Big Bang theory originates, and that's how we get this date of 15 billion years.
Is there a name for that radiation?
Yeah, that's the microwave background radiation. Microwave background radiation. It's 3 degrees Kelvin. Arnold Penzias.
You can even say that even a finite universe is infinite. Just like you can take a line and divide it into infinite amount of points. Maybe time can be divided into infinite amount of points, even within a finite amount of time.
One more question. If indeed the Big Bang started from a pinpoint, can we determine where that point is or what is?
Okay.
Not when.
I'm glad you brought up that question because I stressed a number of times something which is very... Okay, the question was, if the universe began as a pinpoint, where was that pinpoint, and can we determine where it is or was, and if not, why? As I stressed a number of times, it's a very radical change in our understanding of space. We have to think about space as a physical entity, in a sense, and when we talk about the universe, when I talk about the universe in a scientific meaning, I don't mean physical things within some pre-existing space. I don't mean, well, the universe is here and outside there's something else that's not the universe. When I say the word the universe, I mean everything that there is. Everything. Whatever there is, that's part of the universe. All space, all time, all matter, all energy, all thoughts. Everything is the universe. There's nothing outside the universe. By definition, there cannot be anything outside the universe. The universe, when it was small, was not small, a pinpoint, within something else outside it. The universe was small, meaning that space was small. It's a difficult concept, but in the way that if you continue in one direction, you'll go and you'll come back to where you started, not because you're in some kind of a sphere and outside is something else and you're curved in it, but because space is warped. And when space was small, it simply means that everything that there was, there was nothing else beyond everything else that there was, but there was not much room in everything there was. So it was not a pinpoint of stuff within something. It was all that there was, just all that there was. It was not extensive in the sense that we didn't have to go very far to come back to the same point. So there is no point in space now where things began. All of space was that point.
From a scientific point of view, what existed before the now, what if the answer was nothing? No thing.
Nothing already sounds like something. Something is called nothing. By definition, universe means, I don't want to say everything because you say nothing. Universe means whatever.